All right, so 6.1 is going to deal with parallelograms and rectangles. All of chapter 6 is dealing with what we call quadrilaterals. What's the word in quadrilateral that you recognize? Okay, lateral. What does lateral mean? Lateral means sides. What is quad? 4, right? Quadruplets is 4. A quad, like four-wheeler, right? We're talking about 4 things. So in this unit, we are talking about any shape that has 4 sides to it, okay? That's what we're going to learn about. So your first blank there, we didn't do the investigation activity for the sake of time, but it says a quadrilateral. So that's going to be your first blank there, is quadrilateral. Quadrilateral. And remember that quad means 4, lateral means sides. So what are some shapes that you maybe have heard of in your lifetime that have 4 sides? What? A rectangle. What else? A square. Okay. So the first type that we're going to talk about is a parallelogram. Parallelogram. If you would say that for me, please, I'd appreciate it. Parallelogram. Okay. So a quadrilateral is called a parallelogram, and you see that slanted box there? That's the symbol for parallelogram. Okay. If both pairs of opposite sides are parallel. All right, so this means this is your definition of a parallelogram. Parallelogram says both pairs of opposite sides are parallel. Well, that sounds commonplace, right? That sounds like it should be that. So if you look at your little box down there, your example, side AB should have another triangle. So if you want to draw side AB in, it should have another triangle, because it corresponds to CD. So in this diagram, we know that side AB is parallel to side CD. Okay, so AB is parallel to CD. What else do we know here?
AD is parallel to BC.
Good. AD is parallel to BC. All right, so we're going to write that as our second statement. AD, put your segment bars, is parallel to BC. Remember those 2 lines, that's our symbol for parallel. Okay? So when we're dealing with a parallelogram, we're going to have to remember that we have a couple things and formulas that we're going to use to help us. Okay, so if we look at these formulas, they might ask us, are the lines parallel? Do you guys remember how we know if lines are parallel, besides just looking at them? Oh, someone please. How do we know if 2 lines are parallel? What do they have in common? Okay, I'm going to pretend like this is not a reflection of my teaching. Same slopes, right? Say yes, you remember.
Yes, sir.
Okay, thank you. Even if you don't, just say yes. Okay, they have the same slopes. And how do we find slopes? What's that formula? Okay, that's if the line, that's for the whole line, but what if we just want to know about the slopes? Yeah, y1 minus y2 over x1 minus x2. And we use the letter M to represent slope. Okay, and what if 2 lines are congruent? Do you remember how we figured out if 2 lines were congruent? What did we compare? Not their slopes. What do we compare? You're almost to the finish line. The sides, we compared the sides, and how did we know how long the sides were? We compared the lengths. How do you find the length of a line? What formula did we use to find the length? What else means length? Thank you, Chelsea. The distance. So if they ask you if things are the same length, you're going to use the beloved distance formula. x1 minus x2 squared. Please make sure your 1 and 2 are not exponents. They are subscripts. Plus y1 minus y2 squared. Okay, and then if they ask me to determine if something is a right angle, which we're going to need to do, okay, if something is a right angle, remember right angles are perpendicular. So we're going to say the slopes are perpendicular. And how do you know if two lines are perpendicular? What do you know about their slopes? The opposite what? Okay, good. Opposite reciprocal. So you're going to be checking to see if slopes are opposite reciprocal. We're just going to abbreviate. Opposite reciprocal slopes. That's how we know that we have a right angle. Okay, so if they give us a shape and they say, hey, is this shape a parallelogram? We need to check one of three things. All right, you can choose whatever it is that you want to check. All right, so I'm going to give you the option which formulas that you want to use. Any one of the three tests will work. All right, so the first test is if it is a parallelogram, both pairs of opposite sides are parallel. Okay, so let me move my thing. Oh my goodness. That's what you're going to write there on the first line is both pairs of opposite sides. Go ahead and write that. Both pairs of opposite sides are parallel. Yep, letter A. Both pairs of opposite sides are parallel. So if I'm checking that both pairs of opposite sides, is this side parallel to this side? And is this side parallel to this side? What am I checking each time? Look back up there. Underneath the formulas, what did we check? What formula did we use for parallel? The slope, right? So I need to know, is the slope of this side the same as the slope of this side? And is the slope of this side the same as the slope of this side? So how many slope formulas am I going to use? 4. Okay? So I would write that as a note over here, that you're going to need to do the slope 4 times. The second way we can determine if it's a parallelogram is if both pairs of opposite sides are congruent. Okay, so if I have a parallelogram, or what I think might be a parallelogram, and I want to know, is this length the same as this length? What am I going to have to do between those two lengths? The distance, right? I'm going to check the distance of those two. And then, what if I want to find the distance, or what if I want to know if this side is the same as this side? What am I going to have to check?
The distance.
The distance between those two sides. So how many times am I going to be doing the distance formula? If I do twice is checking this side with this side. 4 times. Okay, so again, you get to choose which formula that you use. So this one means that you're using the distance formula 4 times. All right, the last rule that we have, the last where did that come from? Test. Okay. is to see if one pair of opposite sides are both parallel and congruent. So this rule says, and I'll draw it over here with this one. This rule says if you have a parallelogram, or what you think is a parallelogram, and you want to check to make sure it is a parallelogram, you're going to check, just choose one pair of sides. So I can say this side is parallel with this side. And if I'm checking if they're parallel, what formula am I doing? The slope. Okay, so that's going to give me the slope 2 times. But if I also want to see if this side is congruent to this side, what formula do I need to use? The distance, how many times? Twice. But remember, you need to check the same side. Let's quickly draw a diagram underneath each of these so that you know what you're checking for. So if you're checking if both pairs of opposite sides are congruent, this is what you're looking for. If you are checking to see if both pairs of opposite sides are parallel, this is what you're checking for. So again, it's going to be up to you which one you check. If they already tell you that it's a parallelogram, then you know all of these things are already true. You don't have to check them. You just know that they're already true. Okay? So let's do a practice problem. I'm going to erase this. Everybody got it? Okay, let's look at practice problem number 1. It says, assume each parallelogram or each polygon is already a parallelogram. So I am already assuming that these are a parallelogram. So if this is a parallelogram already, then I know that both pairs of opposite sides are congruent. I already know that to be true. And if the sides are congruent, what can I do with each of them? Excellent. Set them equal to each other, right? So if I want to find x, I can say x plus 2 equals 4. I'm setting opposite sides equal to each other. And this gives us x equals what? 2. Okay, now that was a pretty basic example. But if I tell you, now we know that these two sides are the same. So what are we going to do with that? Set them equal to. And then I'm going to add 5 over, and I get y to be 17. Pretty easy example. Okay, so on number 2, we know that this is a parallelogram. If it's a parallelogram, what do we know about opposite sides? They're the same. So how are we going to find x? What? Set them equal to each other. Okay, go ahead and do that. We're getting x to be 4. Now we have a rule, okay, that we haven't talked about yet, but we have a rule that says in a parallelogram, opposite angles are congruent. So let's go back to that page before, the first page. And it says ABC. So let's add part D. Okay, so on that first page, let's add a D that says both pairs of opposite angles is congruent. So I'm not going to move my screen because it'll change everything. But on the first page, number D, opposite angles, well, both pairs of them, both pairs of opposite angles are congruent. So that means in this diagram, this angle is the same as this angle. Those two angles are the same. So if they're the same, what can I do with them? Excellent. Set them equal to each other. Okay, so I'm going to set them equal to each other. Not super hard. Y equals 116. Questions on example 1 or 2? Okay. Example 3 says determine whether a figure with the given vertices is a parallelogram or not. So think about what we talked about. On the previous page, we have 3 different tests that we can use to determine. Except, look what they gave us. At the very end, they said use the distance and slope formulas. So flip back over to your page. If they're asking you to use the distance and slope, what are we looking for? One pair of sides that is parallel and congruent. Okay, so if they're telling you which method to use, we are checking to see if one pair is both parallel and congruent. Now, if that just said distance formula, that means we would be checking the distance 4 times. Okay, so the first thing to do is to do what, do you think? The first, I don't know which pairs go together, so what should I be doing? Drawing a picture. We should be plotting all 4 of these points, and you know how to plot points. Make sure that you are labeling. -1, 4. 2, 1, 0, -1. We should be plotting points. We should be experts at this. X value comes first in the order pair, so you're moving left and right first, and then up and down. Okay, so the first thing then I'm going to do, I'm going to just divide my paper in half because I'm going to have to do 2 different things. The first thing I'm going to check is, let's do parallel first. Doesn't matter which pair of sides do we check. Doesn't matter if I check AB with CD, or do I have to check BC with AD? Does it say? So does it matter which pair you check? It doesn't matter which pair you check, and listen carefully. If one of the pairs does not work, then the other one won't work either. All right? If one of them does work, then the other one does too. Okay? So you don't have to check all of them. All right, so for this formula, if we check the slope first, I'm just going to check AB with CD. So we're going to check, is AB parallel to CD? That's what I'm checking here. All right, so let's check that. Is AB parallel to CD? So if it's parallel, what formula am I using? Slope. So y1 minus y2, x1 minus x2, and I'm using it with these 2 points. Go ahead and do it. Find the slope between those 2 points. The ones up there in the blue, A and B. Check that one first. So the way that I would organize my paper is this. The slope of AB. And then down here I'm going to check the slope of CD. Put your X's on top. Are you getting 1? Okay, so the slope of AB is 1. All right, so now let's check the slope of CD. What's 2 over 2? 1. Okay, so we get the same slopes. Okay, so then I would say, yes, AB is parallel to CD. Yes, AB is parallel to CD. So I know that they're parallel. Okay, so let's go ahead and mark our diagram then. I know that AB is parallel to CD with our little triangle things, arrows. So now if I check that they're parallel, now I need to check to see if they are what? Congruent, right? I need to do the distance. And I'm going to use the same points. Don't use BC and AD now, right? We checked AB and CD, and we have to check the same pair again. So I'm going to check to see, is AB congruent to CD? So the first thing I need to do is the distance of AB. You have your distance formula. I want you to do it, please. If you need to look back, that's fine, or I can put it here at the top. X1 minus x2 squared plus y1 minus y2 squared. We're checking AB first. Don't lose your square root. Carry it down. Are you getting the square root of 8? Okay, so let's now check the distance of C to D. Okay, check your distance CD. You know how to do these. Are you getting the square root of 8? Okay, so RAB, wow, RAB and CD congruent. Yes. Okay, so yes, AB is congruent to CD. And if one side is parallel and the same side is congruent, is this a parallelogram? Yes, it is. So your final answer is going to say, yes, ABCD is a parallelogram. And you have all the work over there to show it to me.
Have the same slope, and they pretty much gonna be congruent.
What did you say?
Yeah, they do have the same slope.
If they have the same slope, they're not always going to be congruent, right? Because I could draw things parallel, but one's longer than the other, right? So, like, I could draw that this is...
So we
Here,
don't,
you can
we don't know exactly that they are congruent.
Right, because look at this shape I'm going to draw up there to the right. Those are the same slope up there, right? They're going the same distance, or they're going the same slant, right? But one is obviously longer than the other. So just because they are parallel does not mean that they're going to be congruent, okay? All right, quickly I want to highlight something on the next page. We're not going to get all the way through it today. Stupid thing. Okay. So the next part of a parallelogram we're going to talk about more specifically is a rectangle. So if a figure is a rectangle, one of the important things is a rectangle has 4 right angles. So that's going to be your blank here. 4 right angles. And you can see from the picture, I have 4 right angles, right? So if ABCD is a rectangle, then it has 4 right angles. But a parallelogram doesn't necessarily have 4 right angles, right? Because look, if I drew a parallelogram, are these corners perpendicular? Do they make right angles in the corner? No, they don't. Okay? So a parallelogram doesn't necessarily have right angles, but a rectangle always will. So some things about a rectangle is that it has 4 right angles. Also, a rectangle is all the properties of a parallelogram, and this is what we haven't talked about necessarily. These things that are all bulleted here, all of these are properties of a parallelogram. So a parallelogram also has these things, and some of them we didn't talk about. So all of those things are true about a parallelogram. If any figure has 4 sides, altogether the angles measure out to be 360 degrees. Okay? So any shape that has 4 sides is 360 degrees, no matter what. If it's a parallelogram, both pairs of opposite sides are parallel. We've talked about this one. We've talked about this one. We've talked about this. Opposite sides are congruent. Opposite angles are congruent. Okay? All 4 pairs of consecutive angles are supplementary. Okay, what that means is this. Let's draw a picture for this one over here. There's a reason you have these listed. If I call this angle 1 and this is angle 2, if I add angle 1 plus angle 2, I should get 180. And then if angle 3 is down here in the corner, if I add angle 2 plus angle 3, I should get 180. So any two angles that are beside each other, if this is 4, what do we know? What makes 180 with angle 4? Angle 1 or angle 3. Okay, so that's what that rule means there. Something new also that we didn't talk about is diagonals bisect each other. Okay, so again, let's draw a diagram of what that looks like. If the diagonals bisect each other, I'm running out of space, so this will be the last thing and then we'll call it a day. If I draw a diagonal, I would draw this picture, by the way. This piece is the same as this piece. And also, this one is the same as this one. That's a rule in a parallelogram. So that's going to happen no matter what. So if I tell you that this piece is 10, what else is 10? The other little piece, right? Those would both be 10. If I told you that this one is 20, what do you know about this one? 20. Okay? So that's a rule we didn't quite talk about without a quadrilateral. All right, we'll pause there, and then tomorrow we'll pick up after your quiz. Please make sure that you are studying for your test tomorrow.